In our last video, we discussed Layer 1 protocols. In this episode, we're going to talk about why some blockchain transactions can be slow and expensive, as well as the importance of Layer 2 solutions. The answer lies in the limitations of Layer 1 protocols. Layer 1, the foundation of any blockchain network, is the underlying protocol where all transactions are recorded. However, it's not without its flaws. Its design can lead to slow transaction speeds and high fees, creating a less than ideal experience for users and developers alike. But there's a silver lining. The world of blockchain technology has evolved to address these issues, introducing what's known as Layer 2 solutions. These are essentially new layers built on top of Layer 1, designed to increase transaction speed and reduce costs. They work by processing transactions off-chain or in a separate layer, alleviating congestion on the main blockchain. Now that we've covered the problems with Layer 1, let's look into Layer 2 solutions and see how they address these issues. Layer 2 solutions offer a host of benefits, making them crucial for the evolution of blockchain technology. First off, let's talk about scalability. Imagine a bustling city with just one lane for traffic. It'd be chaos, right? That's what some blockchains are like. Layer 2 solutions provide additional lanes, processing transactions off-chain or in a separate layer, which significantly increases the overall throughput and scalability of the network. Then we have cost efficiency. If you've ever sent a small amount of cryptocurrency and winced at the transaction fee, you'll appreciate this. By processing transactions off-chain, Layer 2 solutions reduce those pesky fees, making even microtransactions feasible. Think of it like carpooling. You're sharing the cost and reducing the overall expense. Speed is another significant benefit. If you've ever waited for a transaction to confirm, you know that time is indeed money. Layer 2 solutions process transactions outside of the main blockchain, enabling near instantaneous settlements. It's like having a fast-track lane at the airport. Next, we have interoperability. This is the ability to move assets and data seamlessly across multiple networks, like sending a text message from an iPhone to an Android. This ability is crucial for the blockchain world where different networks have unique strengths and functionalities. Lastly, we have privacy. In a world where data breaches are all too common, some Layer 2 solutions offer enhanced privacy features. Transactions conducted off-chain or techniques like zero-knowledge proofs can preserve the confidentiality of sensitive information. It's like sending a sealed letter instead of a postcard. As you can see, Layer 2 solutions are critical in improving the performance and efficiency of blockchain networks. But how exactly do they work? One of the most prominent examples of Layer 2 solutions in the Ethereum ecosystem is the optimistic rollup. Now let's unpack the mechanics behind this solution. At its core, optimistic rollup carries out most of its transaction processing off-chain. This means users can perform transactions at a swift pace and at a lower cost, as they aren't processed directly on the Ethereum mainnet. Next, we have transaction batching. Instead of submitting each transaction individually to the Ethereum mainnet, which may cause congestion and increase gas costs, optimistic rollup ingeniously bundles multiple transactions together into a single rollup. This rollup is then submitted to the mainnet periodically. Now let's talk about optimistic verification. Here, transactions are initially assumed to be valid by the rollup operator. This assumption is, as the name suggests, optimistic, assuming that transactions are valid by default. But what if there's an invalid transaction within the rollup? Well, users can raise a challenge by submitting evidence to the Ethereum mainnet. This triggers a dispute resolution process where the validity of the challenged transaction is determined. Finally, we reach finality. Once a challenge period has passed without any successful disputes, the rollup state is considered finalized and the transactions become immutable on the Ethereum mainnet. With optimistic rollup, Ethereum can process transactions faster and cheaper, while still maintaining its security and decentralization. This is how we are pushing the boundaries of blockchain technology, making it more efficient, scalable, and user-friendly. Optimistic rollup is just one example. Other blockchain networks also employ Layer 2 solutions. For instance, Cardano uses sidechains, while Polkadot leverages parachains, and Avalanche employs subnets. All these solutions aim to enhance scalability, speed, and efficiency, just like optimistic rollup does for Ethereum. In conclusion, Layer 2 solutions play a vital role in overcoming the limitations of Layer 1 protocols, paving the way for a more efficient and scalable blockchain future. Don't forget to like, share and subscribe for more insights into the world of blockchain.